Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai.
Welcome back, everyone. Today we're jumping into an 11th grade topic, graphing inverse functions. Now, if you're new to my channel, I'll be putting timecodes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. Now, as always, if you have any questions about what you see here today or even your own homework, feel free to put it below or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. Now, if you're ready to jump into graphing some inverse functions, hit that like, smash the subscribe button, and let's get started. Now, once again, this video is only going to cover how to graph inverse functions. If you have no idea what an inverse function is, no worries. I have a video talking all about that you can find right up here. It covers how to find your inverse. It even covers when you have an inverse. So check that out and then come back to this one whenever you get a chance. So in order to graph some inverses, let's start with our original function and see what kind of points we're working with. Let's say you have a function like this, in which your x and y coordinates are going to be 1, 2, 2, 5, 3, 3, and 4, 1. Let's graph the function first. So if we were to graph all of these, 1, 2 would be up here. 2, 5 would be all the way up here. 3, 3 would be over here. And 4, 1 would be right here. And if we want to connect all of those, it would look something like that. This is pretty much just graphing our original function. How about our inverse? What does our inverse look like? Let's use a different color to denote our inverse. So if you recall in the previous video, which we talked about how to find inverses, we talked about how inverses pretty much map your range back to your domain. So that means that your range is now going to be your new domain, and your domain is now going to be your new range. So if we start with our points from our f, we can make our f inverse very easily. So we have our x and y points, and if y was 2, x is now going to be 2. If y was 5, x is now going to be 5. And we just continue. Likewise, we're going to swap our y's. So this is going to be 1, 2, 3, and 4. So we're pretty much going to just plot these points. So let's do that. We're going to start with our 1. Now this is not in any kind of order. You can put them in order if you want. It doesn't really matter as long as you plot the points correctly. So 1 is going to go to 4. So this is 1, and we're going to go all the way to 4. So we're going to put that there. We're going to do 2 is going to go to 1 now. So 2 is going to be down here. So 2, 1. 3, 3 is back here. 3, 3. And this time we have a 5, 2. So 5 needs to go all the way out here. So we have a 5, 2. And if we were to connect these, it would look like this. Roughly like that. We're pretty much mapping our range back to our domain. So as long as you have your original domain and range of your function and you know their point values, you can just swap them and graph those points. Once you graph them, connect the points, and now you have your inverse. Let's look at another example here. Let's say you have this function here. X is -1, 0, 1, and 2, while your y's are going to be 2, 4, 6, and 8. So let's graph those as they appear for the function f. So this is going to be our original function f. So we have -1, 2. So we're going to be all the way up here. -1, 2. 0, 4. We're going to be here. 0, 4. 1, 6. So we're going to go all the way up here. 1, 6. 2, 8. So we're going to be even further up here. And if we were to graph all of these, we would look like this. Now, this is supposed to be a straight line. Based on how I drew it, it didn't look all that straight, but this is pretty much a straight line. How would our inverse function look in this case? So I'm going to use once again another color just so we know the difference between the two, and let's figure out our inverse points. So this is inverse, f inverse, and we're going to have our x and y coordinates again. This time, let's put them in order so we can kind of see what they're talking about. It's going to be easy this time because our y's are already in order. So we just swap these, and we're going to swap these. Our x's are going to be now 2, 4, 6, and 8. And our y's are going to be -1, 0, 1, and 2. 2, -1 is going to put us all the way down here. 4, 0 is going to be right on here. 6, 1 is going to be right up here. And 8, 2 is going to be all the way over here. So connecting these points, you see more of a straight line. So I can try to make this a little bit better so you can see the straight line a little bit more. Let's bring this in just a tad bit more, because I really want you to see that this is a straight line, and the resulting inverse is also going to be a straight line. So this is going to be 1, -1, 2. So it's going to be like right here. And there we go. So you see that straight line there is going to be our original function, and we have our inverse, which is also going to be a straight line right here. So graphing your inverse, if you have your regular function points, is going to be pretty simple. All you got to do is pretty much swap your x and y's, and then plot them and then connect them. However, there was one thing that we talked about in the previous video that let us know when we had an inverse and when we didn't. And if you recall, that was when we had something called 1 to 1. Now, what does 1 to 1 mean, especially in a graph? Because we know what it means as far as numbers go, but what does it mean in a graph? Well, 1 to 1 is going to be a special property for our original function. The original function needs to be 1 to 1 in order for it to have an inverse. And in order for it to have an inverse, we say it has to pass something called the horizontal line test. That's what it means to be 1 to 1. Now, we've heard of the vertical line test by now. That's how we know we have a function. But what about the horizontal line test? That lets you know if you have an inverse function, because it tests for 1 to 1-ness. Now, 1 to 1, if you recall, is when every x has an independent different y. All the x's have different y's. No y is repeated for any x. That's how you know you are 1 to 1, and you test that by drawing a horizontal line. If it only hits one time, that means no y is repeated for any x. That lets you know that when you are going to make your inverse, you're going to have a function that passes the vertical line test. And the reason being is, you can probably see it here. This line, our original function f, looks pretty similar to this line here. And that's because we are reflecting over the line y equals x. So the horizontal line test, when you reflect it over the line y equals x, when you find your inverse, you're actually going to have something that needs to pass the vertical line test in order to be a function. When we look at these three examples here, let's identify whether we're going to have an inverse or not. So I'm going to say yes or no if it has an inverse based on passing the horizontal line test, or if we're looking at the points and seeing if they're 1 to 1. So let's look at this first one. Is this graph going to be a function which has an inverse? First off, is this even a function? Yes, it's a function because it doesn't have any one x going to multiple y's. So we know it's a function, but is it going to have an inverse function? Let's check. So this x goes to 2. So -1 goes to 2, right? This x goes to 0. 0 goes to 0. This x goes to 2. Now 1 goes to 2 and -1 goes to 2. Would that pass the horizontal line test? Is this going to be 1 to 1? Are all the y values going to be different for all the x values? No, this is not going to pass because this is not 1 to 1. So this is going to be a no. No, this does not have an inverse function. It might have an inverse relation, but it doesn't have an inverse function because the original function does not pass the horizontal line test. This is not going to be a 1 to 1 relationship. How about this one? Does this pass the horizontal line test? Now, we don't have actual points here, but based on looking at this graph, is this going to be something that passes the horizontal line test? Well, if you put a horizontal line here, you only pass it once. If you put a horizontal line here, you only pass it once. So if you just do your horizontal line test anywhere, there's an odd chance that you might say the wrong answer. Remember, just like your vertical line test, you have to do it for all vertical lines. Your horizontal line test is going to be no different. All horizontal lines should only intersect the graph once. So if you find at least one horizontal line that doesn't do that, you failed your horizontal line test. So this is also going to be a no. It doesn't have an inverse function. It has way too many x's that go to the same y. This is not going to pass our horizontal line test. Let's look at our last example. So this has -5 going to 1, 0 going to 8, and 5 going to 30. Now, assume these are the only 3 points on your graph. Does this pass the horizontal line test? Is this 1 to 1? Well, 1 is only going to -5, 8 is only going to 0, and 30 is only going to 5. So we know this is a function because they all have only one y, but we also know that it's 1 to 1 because none of these y's are repeated. We had a repeated y here, which broke our horizontal line test. None of these y's are repeated, so this is going to have an inverse function. So you can see at a glance, whether you have points or an actual graph, whether your function is going to have an inverse or not. As long as you have the horizontal line test, or you know to check one-to-oneness. If you ever have a repeated y, you're not one-to-one. If you're ever intersecting the horizontal line test more than once, you're not going to have an inverse. So I hope you're following today's video, and I hope you understand that graphing your inverse functions are going to be pretty simple once you have your regular function points. As long as you can swap them and you actually have an inverse function that passes the horizontal line test, you're golden. Now, if you hadn't seen my first video on what an inverse function even is, you should probably go check that one out because that's going to make whatever you saw in this video make a lot more sense. But don't forget, if you have any question about what you see here today or even your own homework, feel free to put them in the comment box below or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. If you haven't done so already, remember to leave a like. It really helps the channel by letting YouTube know this video provided you with some value and could do the same thing for somebody else. And while you're at it, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this is another session of Tutor Me Sempai.